We're going to start all the way up. All right. Number one, we got some questions here. There's really nothing for us to kind of learn that's new. It's just new types of questions to kind of try. All right. We're not really learning any new vocab words. We're not going to do any new processes that we haven't seen before. We just need to read the questions and see how we can set these up. It says triangle ABC is an equilateral triangle. Solve for both x and y. I'm going to look at my picture. I have a triangle. I've got 3 different sides. Those 3 different sides, I can see that one of them looks good. 49 meters. All right, it's a very, very big triangle, but fair enough. But then I have these other 2 sides. I don't know what those are. I'm going to have to find out what x and y is according to the directions. So I'm just going to go ahead and give myself a little bit of a spot to put that there. And we've done these questions before that have x's and y's. And the strategy is ignore the y's, stick with the x's, figure out the x's first, and then later go back and find the y as a second strategy. You cannot solve for x and y at the same exact time. It's not going to work. So let's ignore the y. Let's just work with the x's here. And really the key to the whole question, and really the key to the whole paper, is the vocab that we've learned, equilateral. What does equilateral mean? Equilateral triangles have all the same sides, and if all the sides are the same, if the left side is equal to 49, what's the right side going to be equal to? 49. So we have this now equivalence that we can build where things are all equal to each other. How can we make a nice little formula, a nice little equation? We can say if it's an equilateral triangle, then the left side, how does it relate to the right side? They're equal. You just put an equal sign in there, you go to Desmos, and you get it. So it's a very similar process. We did this kind of stuff before. 49 equals 3x plus 1. We've set up lots of these equations. Zoom out, find the line. It is at 16. And so you know what x equals? 16. This is the equation. That's the whole thing right there. Now this question is easier than most of the questions we're going to get because this question starts off and we already know one of the sides straight up is equal to 49. That means that what we could do is make an equation where we ignore the x's completely and we just say, hey, if we know that the left is 49, what's the bottom going to be? Also 49, right? So this is an easier question. We can use that 49. We can use it twice. We can use 49 to help us solve the right and 49 to help us solve the bottom. The reality is that is only for this question. If you look at the rest of the worksheet, every side has a letter. Left has x, right has x, bottom has x, left has x, right has x, bottom has x, left has x, right has x, bottom has x. So only this first question could we use that strategy. I'm going to use the more typical strategy, which is now that we found the x, let's go back and find the y, right? So there is a little bit of an easier way to do number 1, but I'm going to use our typical strategy. If these are equilateral, they should be equal to each other. 3x plus 1 should be equal to 18y minus 41. But again, you cannot solve for a question if you have 2 variables, and so we need to switch it up and take this x that we have here and plug it into the x value there. So we should have 3 times 16. Again, all of this is a process that we've done before with angles, with lines, with all of this stuff. We've seen this before. Now we're just going to go to Desmos and type in this 16, or this whole thing with the 16. Okay. Again, there are technically easier ways to do this question, but this is our standard strategy. Thank you for going quickly. This is our standard strategy for doing most of these. Click. Do you mind? Sorry, your pass expired. If you make one to Miss Bash, she can accept it. Monte, shut that door for me. Thank you. All right. 3 times 16 plus 1 equals 18y minus 41.
48.
Nope, I zoomed in a little bit too much.
48.
What happened?
48. It's not. It's 5. It's 5.
All right. I'm getting that my y value is 5. What'd you say?
Bro, every time I walk in the hallway, somebody take my mechanical pencils off the side of my bed, bro. My car.
Okay.
Let me catch somebody with
Moving on to number 2. Sorry about what happened to you, man. Moving on to number 2, we get more information. RST is an equilateral triangle. Okay, that means all the sides are the same. Now this one says find x and the measure of each side. So now we're going to need to find x, but we're also going to need to find the side length. Now we actually have a lot of options for number 2. All of these sides are the same, right? So we know that RS, ST, RT, these are all equal to each other. We just got to pick 2, all right? You got a lot of different options, you know, whichever order you want to do it in. Somebody set me up with a little equation for me.
12x minus 22 plus 10x minus 6.
We need to use the equal sign. And then which one you want to use over here?
13x, 10x.
Let's not just say random numbers. 10x minus 6. Okay, so that's the left equals the right. Sure. Are there more options? Definitely. You could say that the bottom equals the right. Because it's equilateral, everything's the same. We have one letter here, so we're able to solve it. Everything's x's, so we're good. 12x minus 22 equals 10x minus 6. Look around for it. What's the number going to be? What'd you get? Jumpy guy. You with us on the notes here?
Yeah.
So what is our x value going to be? 8. Our x value is going to be 8. And once we have the x value of 8, we haven't done this yet, how do we find the exact side length?
Plugging 8 in.
We just plug the 8 in. Now which one do we plug the 8 into?
Both of them.
Now here's what's likely going to happen, okay? There's going to be students who go back to the equation, right?
Oh, never mind. You can just plug
And they plug in it like this, right? They put the 8 on the left side, and they put the 8 on the right side. Now, what's going to happen is no graph. Even if I zoom out, look, this is 10,000, right? No graph. If I look over here, there's not even a graph thing set up here. All right? What we're trying to do is figure out the side length. Do we need 2 sides to figure out the side length? We only need 1, right? What's going on here is that you have this and this. You know, this is just a number. And then you have this. And this is just a number. And Desmos is saying, okay, what do you want me to do? Like, number equals number? Like, that's not an equation. That's not a problem. That's just 2 numbers equal to each other, all right? Delete half of this. Just show me one of these, right? Find one of the sides at a time. We plugged in the 8 and we found 74. If you're struggling to find the side length, you probably have too complicated of an equation going on up here. Okay? We only need 1. Now, it says find the measure of each side, and we have 1. Do we need to do more work?
No.
Why not?
Because there is equilateral.
It's equilateral, they're all the same. And I know that this seems like, Mr. Carr, of course, equilateral, they're all the same, duh. But yeah, there's not much to this. So if you can stay on top of it, remember, We just took a test. This is the first couple days after a test. If you can be really good at this foundational stuff, you're going to be set up well for, like, remember last time we learned the words like corresponding angles and consecutive interior angles. When you guys learned those words in the first 2 days, you did really well on the whole test. When you guys didn't learn those words early, you suffered on the quiz, and then you suffered on the classwork, and then the next week you suffered again on the quiz. So learn this easy stuff. Make sure we know all these vocab, and we'll be good to go. All right, let's speed it up a little bit. If N and P is an equilateral triangle, find X and the measure of each side. This is the same exact thing, right? Find the X, find the side length, and it's equilateral. Everything is the same. Let's go fast. Give me two sides. 4x minus 25, x plus 14. Slap an equal sign in the middle. Go to Desmos. Type it in. 4x minus 25 equals x plus 14. Look on your graph. Try to find it. Zoom in from 25,000, of course. There it is. And what's the number? 13. So my x equals 13. How do I find my side length? Just take one side, right? Don't use this equation where we've got two sides. Just go back to having one side and then replace the x with the number. Backspace, parentheses, 13, parentheses. The number is 27. Do we need to find the other side lengths? We already did, right?
Hold on.
They're all 27. You good with that? Yeah. Okay. And just to prove it to you, right, what's 13 plus 14? 27, right? They're all the same. No matter which one you plug it into, they will all tell you 27. We're good. They're all the same. Okay? Now, you might see a question where it looks like this. It says, like, what is MN? What is NP? What is MP? Right? And it lists all the different sides. And the answers are 27, 27, 27. Right? So if you see something like this, don't be scared. That's just the three different sides. And we know they're all the same. They're all 27. Okay, checking out number 4. We are going to step it up in difficulty a little bit here because we have our vocab word isosceles. Okay? And what does isosceles mean? It means that we have two congruent sides. Be careful. But also low-key angles too. But remember, we're talking about sides here. And it even tells you, I mean, I can tell from the picture, but it tells you that DE and EF are congruent. So when I see DE and EF, those are congruent. Now, I'm going to put these little slash marks in there so that it's super clear to me that these two are the same. And if you want, I might even put a double slash on the bottom to make it extra clear that the bottom is different, right? Because these are singles and this is a double, so these are not the same. Now, it says find x. All right, we can do that. Find x. And find the measure of each side. But now, we're not just going to be able to say they're all the same. We are going to need to get what is the length of DE, what is the length of EF, what is the length of DF. We are going to need these three different measurements. Remember, if you don't put a line on top of those two letters, it means the length of the side or the length of the line. So just writing DE, all caps, is good enough. We don't need to write anything else. Okay, let's make an equation to use Desmos. We need to come up with something that is equal. We only have one option here. Well, I guess we kind of have two because we could do our nice reflexive, you know, but we have 8x minus 13 equals 5x plus 17, or symmetric, I should say. I said the wrong one there. We know that these two are equal to each other. If you use x plus 21 in this equation, you are going to be wrong. You're going to get the answer wrong. Okay? We cannot use x plus 21 because it is simply not equal. Isosceles means only these two side ones are equal to each other. So we go here, backspace, 8x minus 13 equals 5x plus 17. And anybody got an answer? 10. So x equals 10. Now, waiting on you, who can tell me the length of one of the sides? Tell me what DE is, tell me what EF is, tell me what DF is. I'll give you a hint, right? Look at DF. Can you do this in your head? X plus 21? What's x plus 21? 31. All right, and that's DF, right? 31. I can do that in my head. It says x plus 21, that's 10 plus 21, done. Now, are all of these sides 31? No. Are any of the other ones 31? No, right? 31 is going to be different from DE and EF. We know that. It's isosceles. These two are going to be different. Now, these might be a little bit harder to do in my head. I think I could still probably do the right one in my head, right? 5 times 10 is 50, and 50 plus 17, 67. I agree with you, okay? I think that this one's going to be 67, and this one's going to be 67. It's isosceles, so we know that two of them are going to be congruent. Two of them are going to be equal. We got 60, so, you know, when we wanted to find DF, we just did 10 plus 21. When we wanted to find DE, we just did 8 times 10 minus 13. We just plug the number in. Yep. And no matter which one you plug it into, right? 80 minus 13 is 67. 50 plus 17 is 67. So this is not just like us skipping steps. The math works no matter what. Speeding it up, number 5. Number 5 is another isosceles triangle. So because we have an isosceles triangle, again, we're going to have matches. We see that WX and XY, that means WX and XY match. That means WY does not match. It says find X in the measure of each side. So I'm going to find X, and I'm going to find WX. I'm going to find XY. I'm going to find WY. I hate when they use X in the question and X in the question as well, but it is what it is. What does our equal need to be? I see that we have these two that are congruent, so I can make an equal equation right there. 3x plus 4. Type that in Desmos. Anybody solve that for x? What'd you get? 27. I'm trusting, I'm following blindly. So now we need to figure out what each of these sides are. You can just plug them in, right? Just plug the x in here, plug the x in here, plug the x in here. Okay? We're not going to get 3 different numbers. It's isosceles, so 2 of these sides are going to be the same. What did we get? Anybody get any of these side lengths? 85 for yx. That does sound pretty good. I have to agree with you. I think that's perfect. Now, I know one other side as well, right? Because yx is the same thing as wx. It's isosceles. That means wx is also going to be 85. If you want to type it in and figure it out, type it in and figure it out. If you want to use your knowledge of isosceles triangles, use your knowledge of isosceles triangles. Last one, what's wy? You said 103? 104, nice. I was thinking that 3 can't be right, but that's perfect. 104. And I'm kind of trusting blindly. I double-checked XY, but I think we're good. Any questions there? Okay. On the back, if you're looking at what I'm looking at, we're not going to do all these questions. In fact, we might just do like 2 questions or something like that. The only additional challenge here is that we have no triangle drawn for us. So we're going to have to do the drawing ourselves. Draw the triangle. It doesn't have to be a perfect looking triangle, but draw it. I see the letters are P, Q, Q, R, P, R. So it looks like P, Q, and R. So I'm going to put P and Q and R. And I'm going to make sure that I put my things on the right sides. PQ is 18x plus 1. So on the side of PQ, I'm going to put 18x plus 1. Thank you, Jazzy. I appreciate that. It says QR is 24x minus 17. 24x minus 17. And it says that PR equals 15x plus 10. So I'm going to write 15x plus 10. I definitely want to read the question. The information I get is that we have an equilateral triangle. That's definitely the easiest version of what's going on, because we know they're all the same. It gives us a lot of options. It kind of makes it so we can't really mess up as long as we type everything in correctly. And the final thing says find x and find the measure of each side. It's equilateral. So what do we know about all the sides? They're all the same. Okay? You know, we can find the side length, and that should be good enough because they're all the same. Who can make an equation for me? 18x plus 1, that's a good start. Equals, and then pick another one. 24x minus 17. Sure, that works great. Type it in, find the x there. I got the answer. What do you think? Yeah, 3's right. I'm faster than Desmos. Smartest teacher ever. X equals 3. Now, how do we find the side length? Plug it in to one side. Don't plug it in to both sides of the equation. It's not going to work. Plug it into one side. What'd you get? 55. 18 times 3. 55 perfect. That means all the sides are 55. PQ is 55. QR is 55. PR is 55. The last thing before we move on, if I wanted to put hash marks, little slashes on the triangle, how would I label this? Like if I wanted to put the little like slashes like that, how would I do the rest of this triangle? Put them on all three, right? It's equilateral, so you can put one on the left, the right, and the bottom. That means all of them are the same. I know that's not hard. Just wanted to kind of run it by you. Okay, as far as the notes go, we're going to skip all the way down to the bottom. We're going to number 10. Last question that we're going to do, question number 10. We're working with an isosceles triangle. That's a big deal. Isosceles triangle means it has two congruent sides. So when we draw a triangle, I'm just going to try to make it look like that, right? You can either do the tall, skinny one, or you can do the extra wide one, right? However you want to do it. For this question, I guess I'll do the tall, skinny. Next time I'll do the extra wide one, right? If I wanted to label this with the slash marks, the way I have it on my paper is that the tall left and right are matching and the bottom is different. So I'm going to do slash slash on the sides, a double slash on the bottom. Now let's make sure that I label this correctly, because if I start putting my G's and H's in the wrong spot, my triangle is going to be wrong. Which letter goes on the top? I got bad news, guys. There's three options and we guessed both the wrong ones. Because look, GI and HI, so which one are they both sharing? They're sharing the letter I. So I is our top one, right? GI is one side, and HI is the other one. They both share the I. And now, this question has one last layer of difficulty, okay? It's bringing you back to that sad, sad place of Algebra 1. GH is 3 more than X. Yikes. We're going to have to kind of decipher this. We've been skipping over some of these questions throughout the year, but every now and then it is good to come back and see some of these. And today on the classwork, we are going to see some of these. So, if it says GH is 3 more than X, that's not a hard one to do. 3 is the number 3. More than, is that plus or minus or times or divide? That's a plus. And X, just X. So GH, looking like 3 plus X. Or X plus 3, but addition is commutative, they say. Doesn't matter. 3 plus X. Okay? So, GH, handled. Up next, it says HI. It's going to be a little bit more complicated now. It says 17 less than 4 times X. So that's 17. What does less than mean? Minus 4X. But be careful. We have this phrase. You may remember me saying this now. Less than. Less than. Okay? If I tell you guys that my brother is 3 years less than, that doesn't really start my sentence wrong. As far as how old we are, he's 3 less than me. Alright? So, the way you have that set up, he's 3 less than me. Would I set that up and say, hey, my brother's age is 3 less than me, and start with the number 3 and subtract away my age? No, that wouldn't. I'd get a negative number. Right? My brother's not a negative years old. If I said my brother is 3 years less old than me, the less than actually ends up needing these to be switched. I don't know that I explained that super well, but the bottom line is less than, you got to switch the order of these two things. Okay? So, our actual HI is 4x minus 17. What did you say? And we have one last one. It says GI is, and look, we get a perfect opportunity to practice. Less than comes back to haunt us again. Less than means that the order needs to be switched around. So instead of 45 minus 6x, it needs to be 6x minus 45. At the end of the day, it ain't that hard, just switch the order, but it's definitely tricky, okay? That less than, all the way back in Algebra 1, we did learn this, it was on the SOL test. You got to switch those orders. Okay, now we can finish this question. We're going to go quickly. It says find x, find the measure of each side, okay? So that is GI, HI, and GH. Obviously, if yours are in different orders, that's okay. If yours have the different letter order, that's okay. We need to come up with an equation, and it's very specific. It has to be 6x minus 45 equals 4x minus 17. We have to choose the equal sides that are isosceles. We have to choose these two. We set them up. We type it in. I agree with you. 14. Once we get the x, we need to find our side lengths. Then we need to plug that in. Yeah, you plug in the x there, sure. 6 times 14 is 84 minus 45 is 39, is that right? Do we know another one is 39, or is that the only 39? Which one's 39? The other one, which is HI, which is 39. And I think we can do this in our head. What's 3 plus 14? 17. Okay. We have to be able to handle these questions. Take your time when you read them. The bottom line is they're not going to be crazy complicated setups. It's going to tell you a number. It's going to tell you you're either adding it or subtracting it. It's going to tell you a number with x. Remember, less than. That is the trick. Less than means switch them around. The last thing, we did questions on the front where they draw the triangles for us. We did questions on the back where we have to draw our own triangles. That is part of geometry, is that you know how to draw your own triangles. Don't expect to go for the next 2 weeks without drawing a triangle. You might as well get started now. We're done with the notes. We'll do classwork after lunch.